Hello.
Hi everyone, good morning to all of you present out here, all professors, faculties from different colleges and from SIT. This is the second day of faculty development program. Now, before I start, I just wanted to make sure, am I audible to everyone?
Yes, sir, you are audible.
Okay. Okay. Now, today's session is about the technical and economic feasibility and study of electric vehicle. My name is Ranjan. I'm from Siliguri Institute of Technology. Today's presentation will be done by Dr. Suman Mazumdar, Assistant Professor, NIT Mizoram. Now, the topic itself is very interesting because it's all about electric vehicle, the technical and economic viability and feasibility. The much talked about electric vehicle, which is supposed to be the alternative or the only solution that we are walking towards. Now, before I call upon Dr. Suman, I would just like to introduce the speaker for the day. Dr. Suman received the BTech degree in electrical engineering from National Institute of Technology, Agartala, India in 2010, and the MTech degree from National Institute of Technology, Agartala in 2012. He completed his PhD degree in electric and electronics from National Institute of Technology, Mizoram, India in 2021. He's serving as an assistant professor in electrical and electronics engineering department, National Institute of Technology, Mizoram, India since 2012. His publication list includes more than 10 national and international publications. His current research interest includes electric vehicles, smart grids, smart transportation system. So the list is long, and sir is here with us. So without further ado, sir, I would now welcome you to the dais and start off with the session. The FNA, the question and answer session we'll be doing at the last. You can just go ahead and ping in your questions at the chat box, and hence we can start with the question and answer session. So here we are with you, sir. The
Okay.
dice is yours. Thank you.
Okay. Thank you, Ranjan, first of all, for the introduction. And a very good morning to all. Am I audible to you all?
Yes, sir. You are audible.
Okay. Thank you. Uh, First of all, I would like to you all in this session is the session for only for one hour. So the topic is I already Ranjan already mentioned technical and economic feasibility study for the e-mobility. Okay, so during this session, what I will do, I will just mute my video so that I can save my bandwidth, and I'll share my PPT. Okay, so is the slide visible to you all? Hello, Ranjan. Is the slide visible to you?
Yes,
Yes, sir.
sir.
It is.
Okay, okay, thank you. So, as the session is the lecture for 1 hour, so it's very difficult to explain in detail. So, I will try to highlight some important points for the e-mobility system. The topic that I have choose for the today's lecture, that is the e-mobility system.
Sir, you are not audible.
Do if you are considering electric vehicle, two-wheeler, three-wheeler, four-wheeler, or the electric bus also. In that case, the parameter sizing is important part. The parameter, without parameter sizing, you cannot go for electric vehicle. So just I'll give you some hint that how we can go for a system sizing and all algorithm. Obviously, whenever we are using the various electronics component, power electronics component or various converter, so we need a controller, we need a proper controller from charging to, from source to battery, battery to wheel, whatever the converter we are considering in between, that converter need to control with a good controller. So that also I will show you through a algorithm. And then finally we will discuss about, I will discuss about economic analysis. Economic analysis is very important part for the electric vehicle. Whenever we are comparing with the existing electric vehicle, you can say the ICE vehicle. So we have seen that the cost is, initial cost is quite high for the electric vehicle. So the customer are not satisfied with that cost. They are not want to, they are not willing to buy all that high cost electric vehicle. So how we can encourage the customer to buy all these things with the economic analysis, that I will show you.
Sir, so
What?
sorry to interrupt, sir. Your PPT is not visible, sir.
What? The slide is not visible?
Yes, sir.
Let me check once. This will help us to encourage the customer to buy the electric vehicle. Okay, so the thing is that if I see the scenario, emission scenario globally and in India also, you can see the first figure. If I see the work air quality index, India is in third position. So that means that the air quality index in India is very poor. After China and Bangladesh, Indian air quality index is 157. So very soon we should take some step to reduce the emission from the environment. So that is giving an alarming call for us. And in the figure two, if I see in the sector wise, if I see the emission, then the transport sector is globally, I am talking about the globally, 13% emission that we are getting from the transportation. So this is the option that we have. If we go for an electric vehicle, if we can go for a 100% electric vehicle, obviously with the renewable energy source, then definitely we can reduce that 13% emission from the transport sector. And the figure 3, you can see that again, if we classify that one, that the sector wise, if I classify the transport sector emission, in the transport sector emission, the most emission is coming from the road transportation. You can see that the globally 80% emission that we are getting, that is from the road transportation. So immediately if we can target the road transport vehicle, and if we can convert into an electric vehicle, then we can get a good solution from that. And then again in the figure 4, you can see the classification of the vehicle, the what percentage of vehicle that we are using in case of road transportation, that also get from the figure 4, and then you can target that particular vehicle, that the bus is 29%, two-wheeler is 8%. So that is the contribution of the emission. So the most contributing road transportation is the goods vehicle, the 30% vehicle, 30%, 35% emission we are getting from the goods vehicle, and the 29% we are getting from the bus. So if we target these two along with the other three-wheeler or four-wheeler, so we can get a good benefit in case of emission reduction. Now the again in this figure, the detailed classification you can see for the greenhouse gas emission. The greenhouse gas emission, the energy sector is obviously the polluting more. The 73% emission that we are getting, that is from the energy sector. So we should think for that. And the industrial process and the product use is 8%, agriculture sector is 16%, and waste is 3%. So the most of the emission, and in if I see the sector wise, is coming from the energy sector. So that all these details is gives an idea that where we are polluting more. So obviously you can see that the energy sector, the one thing is that the energy sector is polluting more. Second thing is that the transport sector is polluting 30% emission, and among the 13%, road transportation sector is polluting the more, is near about 80%. So this idea we are getting from all this data. Now so okay, so we understood that yes, the huge emission in the environment, and the electric vehicle can be option for the emission reduction. Now before implementing an electric vehicle in the market, we need a proper system, because without any system you cannot get the success. People are using the electric vehicle, sorry, public vehicle. The private vehicle. The reason is that we have a public vehicle, we have a city bus, we have a government buses, other buses also, but we are not using that buses due to many reasons. One is that we don't know that what is the timing of the bus, and we don't know that there is a seat available for the passenger or not, or the bus nowadays whatever the city bus is running, there is no AC, or because the people are not comfortable with all these things. So there is some issue due to that, what people are avoiding that public buses and all, and then people are encouraging with the private vehicle. So they are taking the private vehicle for their purpose. So now we need a system, because if we go for the public vehicle, what we can do, we can reduce the congestion from the road, as well as we can reduce the emission, that I will show you later. So so we need a proper system. The first we need a user system interface. So if you are coming with a system, your system should interface with the user. So then people should know the information of the bus, so that need to be highlighted in the every bus stop. So that thing you need. Decision making by TCC, transportation communication center. There should be a transportation communication center where they will collect all the information from the passenger, and they will give the transport sector. And inter-system communication, obviously the intercommunication system is the how many passenger are there, what is the grid status to charge the electric vehicle. So all this information you should incorporate in your system to get the success by implementing the electric vehicle. So I'm not going through the details, as we do not have much time. So this type of system overview we need to get a success from the electric vehicle. So obviously and if you have this system, then only we can go for a technical and economic feasibility study. So the important thing is that before implementation of any electric vehicle, any type of vehicle in the market, so you should have a technical feasibility as well as the economic feasibility. In the technical feasibility so this is the system architecture that I have given. If you design a system, or if you trying to implement in a electric vehicle which will be running on the Indian road. So this type of system you need a grid energy, you need a solar energy, or you need a renewable energy, you need a battery. So all these component basically I have shown in this architecture, and how they are connected to the system, that also is given. So now the main important thing is the grid and renewable energy. So whenever you are talking about that, you are planning to implement a electric vehicle in the market, so you need to charge the vehicle. How you will charge the vehicle? So you need a grid energy, or you need a solar energy or renewable energy. I am talking about the solar energy. The reason is that the India the solar energy is available in every location in India. So that's why whenever you are talking about the most of the generation basically you are getting from solar. So considering all these things, you should design a system. So obviously this again, as I mentioned, that whenever you are talking about this transport system, with the electric vehicle, you need a controller. The controller will act a very important role, like that. If it is connected, if your vehicle is charging from the grid, so you should know the grid status, because as we know that the Indian grid already is overburdened. Along with that, if we connect the electric vehicle to the grid, there may be the more issue will create. So for that, always you need to check the voltage profile of the grid, as the grid is capable to charge the vehicle, charge the electric vehicle battery or not. So that all this function is coming, or all this responsibility is controller. So controller will measure all the parameter for all the component, like the ACSD. Basically we are considering the high capacity storage device. As I have shown in the architecture, that in the architecture we are using a battery. Battery is connected to the PV, you can see. So this is the battery that we are placing in the charging station, that will be charged from the solar energy, and then it will charge the electric vehicle. So your controller always need to check all the parameter, like from the grid parameter, for battery parameter, load parameter, and the passenger information also. Based on them, controller need to take action, and then only you can get a success from the system. So I am not going through this. This is the various communication link that you should have in the system to maintain a proper communication in different entities. Now the lot size, all this parameter. If you are considering a solar PV for your system or in your location, so you should know that what size of PV panel you should install in for the particular bus stop. And as well as you should know the size of the battery, and you should know the size of the charger, and as well as the obviously the based on the number of buses, passenger capacity, considering all these things. So the sizing is very much important. So here basically I'll show you the battery sizing, system sizing. In this is the example that I am showing, that we have analyzed, and we have published few paper from this analysis. So you can see there are two analyses basically. System sizing, the step is the one is the SP sizing, solar panel sizing, and another one is the SCHD sizing, the high capacity storage device sizing. To size the solar panel, the two important thing that you need to consider, this is the solar irradiation. If you are in a Kolkata, and if you are planning to design a charging station for a particular bus stop, so you need to measure the solar irradiation data for that particular location. And then as well as you need to check that how many bus are stopping at that particular bus stop. So that means you need how many batteries, electric vehicle battery will be charged from your charging station, that you need to check, then you need to measure. So if you know the irradiation data for the solar panel, and if you know the energy requirement for the transport sector, considering all this step, you can get the solar panel size. The reason is that if you are not sizing it properly, then what will happen? Maybe the 50% or 20% electric vehicle you can charge, other vehicle you cannot charge, as there is no charge available in the charging station battery. So the proper sizing is very much important. Another one is the storage. Storage is here we cannot depend fully, we cannot depend on the renewable energy, as we are not in a stage that the India, the renewable energy generation is not that much. So we can make a combination of the solar and grid. Later I will show you that with this combination are we getting any benefit or not. So if we are considering the combination for the solar and grid, what we can do, that whenever the grid is overloaded, so no need to charge from the grid. You just take the solar energy to charge the electric vehicle, and whenever the grid voltage is quite good, like at the night time, whenever the load is less on the grid, during that time, what if the voltage profile is good, then that time also, that time you can charge the electric vehicle. Okay, sorry, charging station battery, and which will give the supply to the vehicle battery throughout the day. So if you plan such a way, then what you can get a good system which will support the whole system to maintain a energy flow for 24 hours, and it will help the vehicle to run on the road 24 hours. So the system sizing is very much important. So again, obviously the algorithm you need, as I already mentioned, that before charging or discharging the battery that we are considering in the charging station, so you need an algorithm. That algorithm you need to incorporate in the controller, and accordingly the controller will action. So there are few parameters that we are considering. One is the voltage per unit, that the energy from the solar panel, SOC of the battery, and the energy is available in the ACSD high capacity storage device. So all these parameters that first you need to measure. Then you set some parameter for the controller, that if you are, maybe if you are considering the voltage per unit, if the voltage per unit is quite enough means in this analysis we have considered 0.995. If it is 0.995 or above, then you can charge the vehicle from the grid. If it is less than this, we are not charging the vehicle from the grid. SOC, you know that the SOC, state of charge of the battery, if it is above 50 and the grid is not available, then we can do, the battery can discharge to charge the electric vehicle. Otherwise, what will happen if the SOC is less than 50%, then it will charge from the solar panel or it will charge from the grid. So these are the algorithm throughout the for charging and discharging we have considered, and this algorithm will help you to controller to take the decision. So if this is the system that you know that your system should work such a way, based on that you can design a maybe for the other parameter, for maybe for the other system, the for maybe for your location you need such a system, so there the algorithm will be different. So that algorithm you can design as per your location, as per your requirement, and then that algorithm you can incorporate in the controller, and then the controller will act accordingly. So now based on this algorithm, am I audible to you all?